Hello everyone, I'm Abdul Moy and this is my project for Gemini 3 hackathon AdOS, which is a multimodal AI video analytics tool. Video ad analytics is a multi-billion dollar industry. However, the analytical side remains stuck in a manual bottleneck. Marketers spend countless hours manually tagging videos to understand brand placement and creative engagement. So the traditional computer vision systems are generally just flat object detection. They don't handle all the nuances in an ad offers. This tool specifically built for those use cases, and it uses Gemini 3's partial reasoning, which makes it even better. And I'll just walk you through the system. This is the dashboard you'll see. Currently, I'm running localhost because the the web deployed version runs on CPU, which it can be really slow. So I'm running on my personal GPU. So you can just drag any video you want to analyze. Let's analyze video 20, video 13 and let's do this. As you can see on the left side, it's logging some stuff. I'll go over the system architecture while it's running. So this is a high level system architecture. We use a fast API to ingest the videos, which extracts frames and audio and processes them parallelly. So from the frame side, it detects the scenes, then extracts the candidates it wants to it process, and then we do a three-step deduplication, which is first one is using a perpetual hash, bhash, and weblet hash to do all the heavy lifting on removing the near duplicate frames, and this one is perpetual similarity. We are using LPIPS. It's a neural net that uses visual if frames are visually similar, it just removes it, and then we use semantic matching using clip embedding system to remove the uh, semantically similar frames. And on the then after everything else we use NMS plus k-means style importance scoring, and on the other side we extract the audio using ffmeg, and then you use OpenAI's whisper to detect phrases and analyze basically our audio, and we do a mode analysis. After all that, we send these to Gemini 3 preview and we get a structured JSON output. If we go back there, we will see these are the outputs. The ad was from Domino's, and if we want to oh, look at the ad, that is basically
Domino's Best Deal Ever is back. Any hand tossed pan,
this
thin
basically,
crust,
as
or
you
New
can
York.
see, it's a Domino's ad. So it clearly got it right. So it's getting us the topics, the pizza, like the product, the engagement, etc., and the visual elements targeted where it's targeted. And these are the keyframes that we sent. As you can see in the statistics, initially sampled was 92 frames. This is a video at 30 FPS, and this is a 14-second video. And on 14-second, 30 FPS would be more than around 100 ish. So we're getting to, 92 frames sampled, and finally after all the duplication, we only sent five 5 frames, and this is a 94.6% reduction. And as you can see, the hashing system removes 38 frames. Then our perpetual layer removes 27 frames, and the clip removes 13 frames. And here are all the logs. You can see these are basically doing what I just explained. And yeah, So after our pipeline, there was 13 candidate frames were were selected, but after that we use our importance scoring using our representation, and we only select five. That's basically it. Also, you can use the terminal to do it. So this is something I ran before this to save time. So this was the video number 5 if you want to watch that.
Here with friends and family.
So this is the ad, and as you can see in that ad, there was not like if you look at the ad, there was the the logo itself wasn't present like in a text. It was present in this frame.
I'm feeling the love.
As you can see on the 3 seconds here, it's visible out of all the frames, but our system got that, and and the total frames sampled was 119. After deduplication, it was 35, and after our importance scoring, we only sent 12 frames, which was 89.9% deduplication. And yeah, basically this is the schema that I selected, and yeah, this is basically a lot flexible. Anyone can like select what they want to extract, and I specifically extracted this because of I talked with some of the industry leaders who said this was the things they kind of use day to day. And I also used a data set from University of Pittsburgh that I have cited in both the README and the technical report. And these were the categories they were using, and these are the topics and sentiments they were using. And I ran my benchmark on 50 videos from the data set, and we got the results of these are the results we got from it. So as you can see, almost in all of the metrics, our full pipeline wins, and these were tested against the human annotated benchmarks. So as you can see, it's clearly our system is better than uh, any other sampling system like single sampling or uniform sampling or vision only sampling. In terms of API cost, it reduces the API cost from 48 cents per video to 0.05 cents per video, and it's a huge saving in cost if you are analyzing hundreds of thousands of videos, and it also saves the environment. As we know, vision language models uses a lot of water to cool it down, etc. So yep, this is more or less, and this is the GitHub repository. Thanks for watching, and if you have any question, please reach out. Willing to answer any question you have. Thank you very much.